welcome to G Fun Facts Online. We often think of our modern world as geologically calm. The last 700 years, an epoch known as the Holocene, has provided a stable climate that allowed human civilization to blossom. But this perception of tranquility is fragile. The cosmic shooting gallery our planet flies through has never closed, and a recent discovery in southern China has shattered our comforting illusions about the recent past. Hidden in plain sight, a monumental scar has been found, a discovery that rewrites our understanding of catastrophic impacts during the age of humanity. This is the story of the Guangdong crater. For a long time, this vast, bowl-shaped depression in Guangdong province was mistaken for a natural feature, a product of erosion in a landscape known for heavy rainfall and rapid weathering. The idea that an impact crater could survive for thousands of years in such a humid subtropical environment seemed impossible. But a team of researchers led by Dr. Ming Chen saw something others had missed. Their investigation wasn't a lucky accident. It was meticulous geological detective work. The depression's slightly elliptical shape and its rim, with an elevation difference of nearly 200 meters, were initial clues. But the real proof, the undeniable smoking gun, was found at the microscopic level. Inside granite fragments scattered across the crater floor, they discovered what are known as planar deformation features, or PDFs, in quartz grains. These are not simple cracks. They are incredibly fine, parallel layers of glassy material that can only be formed within the crystal lattice of quartz when it's subjected to the immense shock pressures of a hypervelocity impact. The pressures needed, between 10 and 35 gigapascals, are simply not produced by any known process on Earth, like volcanoes or tectonic shifts. As Dr. Ming Chen stated, on Earth, the formation of planar deformation features in quartz is only from the intense shock waves generated by celestial body impacts. This was the irrefutable evidence. The landform wasn't a valley. It was the scar of a violent, instantaneous event from space. The confirmation of the Jinlin crater, as it's officially named, was significant. But it was its colossal size and surprisingly young age that sent shockwaves through the scientific community. With a diameter between 820 and 900 meters, the Jinlin crater absolutely dwarfs all other known impact structures from our Holocene epoch. To put that in perspective, the previous record holder was the Macha crater in Siberia, which measures about 300 meters across. The Guangdong crater is 3 times larger. This discovery forces a complete recalibration of how often and how violently our planet has been hit in its recent past. Dating the crater revealed it to be remarkably young. Based on the chemical weathering rate of the local granite, which was only partially weathered, the team estimated its age to be in the early to mid-Holocene, younger than 700 years old. Some reports suggest an age of around 10,000 years, placing the impact squarely in the time frame of humanity's transition to agriculture and settled societies. The impactor is believed to have been a meteorite, probably around 30 meters in diameter. The energy it released was staggering, estimated to be equivalent to 600,000 tons of TNT. That's about 40 times the power of the atomic bomb dropped on Hiroshima. The fact that the crater is so well preserved is a geological marvel. It's nestled within a thick crust of weathered granite, which seems to have acted like a protective armor, shielding it from the erosive monsoonal climate. This unique setting has given scientists an unparalleled opportunity to study a large, young impact crater in a high-erosion environment, a true rarity. The Guangdong crater doesn't exist in a vacuum. Its discovery adds a huge exclamation point to the growing list of Holocene impact events. Before Jinlin, the Macha crater field in Russia was the largest known. Formed about 700 years ago, its largest crater, now part of a lake, is 300 meters wide. Then there are the Kaali craters in Estonia. This field, formed by an impact around 1600 BC, includes a main crater 110 meters across. The island was inhabited at the time, and the event, equivalent to the Hiroshima bomb, had a profound effect. Pollen analysis shows a temporary collapse of local agriculture, and the crater became a sacred site for the Bronze Age people, who even built a stone wall around it. In Australia, the Henbury craters, formed 700 years ago, are exceptionally well preserved in the arid climate. And in Argentina, the Campo del Cielo field contains at least 26 craters from an impact 500 years ago, leaving over 100 tons of iron meteorite fragments scattered across the land. These sites, now joined by the colossal Guangdong crater, prove that the age of civilization has been repeatedly punctuated by violent intrusions from space, far more significantly than we ever realized. So what would it have been like to witness the Guangdong impact? The raw power, equivalent to hundreds of kilotons of TNT, would have unleashed a torrent of destruction. Drawing on our understanding of events like the 1908 Tunguska airburst and the 2013 Chelyabinsk meteor, we can paint a terrifying picture. First, a powerful blast wave would have radiated outwards at supersonic speeds. The Tunguska event, a 10 to 15 megaton airburst, flattened 80 million trees over 2,000 square kilometers. The Guangdong blast wave would have been devastating, leveling forests for many kilometers, snapping trees like twigs. The much smaller Chelyabinsk event, from a 20-meter object, produced a shockwave that shattered windows and injured over 200 people. Guangdong's impactor was larger and hit the ground, making its blast wave incredibly destructive. Simultaneously, an intense burst of thermal radiation, a flash of heat and light, would have incinerated vegetation and caused severe burns to any living creature exposed. It would have ignited widespread fires, though some may have been blown out by the ensuing blast wave. The impact would have also sent powerful seismic waves through the ground, triggering a significant regional earthquake, causing landslides in the mountainous terrain. Finally, the impact would have ejected a massive plume of dust and debris into the atmosphere. While not an airburst, the ground impact would have had significant atmospheric effects, potentially leading to temporary cooling by blocking sunlight and the formation of acid rain. This wasn't just a geological event, it was a regional catastrophe. The fact that impacts of this magnitude occurred during the rise of human civilization raises a fascinating question. How did these events affect our ancestors? Direct historical records are scarce, but we can find echoes in mythology, folklore, and archaeology. The sudden appearance of a brilliant fireball, followed by a cataclysmic explosion and a permanent scar on the land, would have been a terrifying, awe-inspiring event. Across cultures, meteors were seen as omens, messages from gods or harbingers of doom. The Kaali impact in Estonia is a prime example. The crater became a sacred site of ritual sacrifice, a clear sign that the terrifying event was woven into the fabric of local mythology. The Campo del Cielo site in Argentina, meaning, quote, field of heaven, shows a deep cultural connection to the celestial origin of the iron masses found there. The discovery of the Guangdong crater, in a region inhabited for millennia, opens a new chapter. Could the memory of this cataclysm be preserved in local myths? Is there archaeological evidence of a disruption to human settlement around 10,000 years ago? These are questions that researchers are now eager to explore. Beyond ancient history, the Guangdong crater is a stark and timely wake-up call for us today. It's a potent reminder that the threat of asteroid and comet impacts is a clear and present danger. The fact that a crater of this magnitude could remain hidden for so long in a relatively populated region highlights the gaps in our ability to detect these threats. This brings us to the field of planetary defense. Its goal is to find, track, and characterize near-Earth objects, or NEOs, and develop strategies to mitigate an impact. The threat is very real. The Chelyabinsk meteor in 2013 was caused by an object only 20 meters across, yet it caused widespread damage and injuries. The Guangdong impactor was significantly larger. An impact of that scale in a modern, densely populated city would be catastrophic. The first step is finding the threats. NASA and other space agencies operate a network of telescopes to scan the skies. While we have found most of the largest kilometer-plus-sized asteroids, we have only found a fraction of the smaller, but still devastating objects in the tens to hundreds of meters range. The Guangdong crater is proof that these objects can and do hit us without warning. Once we find a threat, we need to be able to stop it. Several deflection techniques are being developed. The most mature is the kinetic impactor, essentially crashing a spacecraft into an asteroid to nudge it off course. NASA's DART mission successfully demonstrated this in 2022. China is also planning its own kinetic impactor mission. Other methods include a gravity tractor, which uses a spacecraft's own gravity to gently tow an asteroid, or even laser ablation. Planetary defense is a global challenge that requires a global response, and this discovery only underscores the urgency for international collaboration. The discovery of the colossal Guangdong crater is a landmark achievement that has fundamentally altered our understanding of Earth's recent past. It's a story of scientific curiosity that has revealed a cautionary tale. It's a stark reminder that we live in a cosmic shooting gallery, and the threat of impact is not a matter of if, but when. The silent, verdant hills of southern China have given up their 10,000-year-old secret, a message written in stone and shockwaves that we must heed. The Guangdong crater stands as a silent sentinel, a reminder of the unseen threats that lurk in the darkness of space and of the urgent need for vigilance, preparation, and the continued quest for knowledge, which remains our best and only defense.